To conduct magnetic resonance imaging, commonly referred to as MRI, for cardiovascular imaging models, traditionally, human subjects are needed. These people need to stay still and refrain from breathing as additional motion can distort the images. The solution to this is to create a pump and subsequent phantom heart which can emulate cardiac motion so that imaging research can be conducted without the need for volunteers. Enter the Phantom Cardiac Pump and Control Unit, designed by a group of electrical and computer engineers at the University of Iowa for a senior design project. We are Team Sparkbug. The sponsor of this project, Dr. Matthews Jacob, ECE faculty at the University of Iowa, studies and advances medical imaging using machine learning and artificial intelligence. As time and availability for an MRI can be costly and access to volunteers can be difficult, there is a practical need for a cardiac phantom for rapid and independent imaging capabilities. With the Phantom Cardiac Pump, the device gives the ability for MRI researchers to replicate the effects of a human heart by allowing for speed, volume, and phase control. This device uses stepper motors, syringes, and an Arduino at its core to create the pumping system. Comparable devices on the market only allow for speed control and require manually changing the volume and synchrony of the phantom heart's chambers. With our design, not only can volume and offset be changed through a computer application, but the parameters can be set for each chamber independently. The heart rate is also variable on the computer program. The Phantom Cardiac Pump and Control Unit is much more cost-effective than existing options, coming in at around 10% of the cost of similar devices. Here is a demonstration of the control application for the Phantom Pump and Controller. The Phantom GUI control application is a standalone executable which can run on Windows, Mac, or Linux, and it is used to send real-time commands to the pump's control unit, which will change how the pump operates. It begins by selecting the COM port of the control unit and then connecting to the device. After connecting to the device, we're able to set the volume. Here we'll set them to 50s. This is milliliters. It'll move the pumps. It takes a few seconds, so we've sped it up for sake of time. After the pump volumes have been set, we can set an offset on there. 50 corresponds to 50% or 180 degrees of a phase shift. It moves the pumps accordingly. We're also able to get the status of the pump currently, 60 beats per minute. We can start the pumps, and there you'll see the phase shift. Here we can change the heart rate from 60 to 80 beats per minute. And here we can stop. This Phantom Cardiac Pump and Control Unit were designed with simplicity and control in mind. This device will be able to assist in advancing the field of medical imaging, and there is great potential for its success and application in medicine. Thank you again to the sponsor of this project, Dr. Matthews Jacob, and thank you to the group of biomedical engineering senior design students who developed the Phantom Heart shown throughout this video. The success of this project wouldn't have been possible without their contributions and support.